because we got a lot to cover today. Hi, my name is Jeanne Ohren. If you don't know me, I'm with the Genie Project Office. For the last couple of years, I've been working with the instrumentation and measurement projects. We usually do tutorials on the first day, and then on the second day, we'll do this demo session to show you some of the new features and capabilities of the tool sets. We flipped them around this year to try out showing you some of these capabilities before giving you the chance then to jump on hands-on and try them out yourself. We thought it would help you decide if which one you wanted to see or both. We're going to have them at separate times this year, so if you want to try them both out, you can try that out. And so we're going to go through, have demonstrations by each of the different projects of their new capabilities, what these tools can do, and hopefully please ask questions along the way and let us know what you want to know about these instrumentation tools. To start out, I'm just going to give a really brief overview for those who aren't familiar with the tools, but I think most of you are. I want to give time to the projects to show you the more interesting stuff. So there are the two different projects, GEMINI and GIMI. GEMINI is based on two tools called LAMP and InstTools that were around. Both sets of tools have a software that runs on the nodes within the slice, typically called the measurement collectors, and they also have persistent services that run outside the slice. For GEMINI, the measurement collectors are called BLIP. They provide a really rich set of active and passive measurements, and they're extensible. The services running within outside of the slice are UNIS, which provides the topology and service information, as well as the measurement metadata within a central node. And then the measurement stores collect the data from the collectors and to present to the user or to be able to archive them off. The user interface to GEMINI is called Genie Desktop. It provides the configuration and visualization of the tools and various operations on the resources as well, outside of just the instrumentation tools. So GEMINI makes it really quick and easy to install and configure the measurement collectors within your slice, to schedule your active measurements if you want to do active versus passive, and to access the live graphs and data throughout the experiment as well as archive them after, and then perform operations on one or many of your resources at the same time. GIMI is based on OMF and OML tool sets. There's an existing set of what we call OMLified measurement tools that provide a wrapper around the tool to collect the measurements and put them into the OML database. It's easy to add support for other measurement tools. If you have your own tools that you want to use to capture your measurements, you can also do that. And the services outside of the slice are the OML server, which collects those measurements. The messaging server supports OMF, which is used to control the measurements as well as the experiment. And then the user interface for GIMI is LabWiki. And it has the ability has three different panes to plan, design, and execute experiments using a definition language called OEDL. And it has a pluggable architecture if you want to support other tools. And GIMI makes it really quick and easy to orchestrate both your measurements and the experiment tasks as you go along. It allows you to parameterize and repeat your experiment. So if you want to try something out, tweak it a little bit, you don't have to rewrite your scripts. You can parameterize and change things along the way, as well as run closed-looped experiments. And then it allows you to record notes and capture graphs along the way. So you can save those off with each run of your experiment. So, and that's just a quick overview. The developers are going to show you what each of these tools can do, but after this, if you want to learn more about it, if you want to get your hands on, you can come to the evening demos tonight. Both the tools are going to have demonstrations, and it's an opportunity to ask more questions of the developers. Tomorrow we have 2 hands-on tutorials, one, like I said, one for each at different times. So you can learn how to use Gemini and the Genie desktop at 11 o'clock tomorrow, and GIMI and the LabWiki tools at 1:30. And then there's also an advanced OpenFlow using LabWiki on Wednesday morning. So with that, I'm going to turn it over to the guys to show you what these tools can do. We're going to start out with Gemini. So I'll have Jim and Hissam show you the new Genie desktop features.
Since the last time. So if you're not really familiar with the Genie desktop, I would really recommend that you come to our tutorial tomorrow where we talk about all the features of the Genie desktop, how to use it, how to actually use it in your own experiments, and so we're going to give a hands-on tutorial on that aspect. Today what I would like to do is just talk about some of the new features that we've added more recently. Now, the good news is that if you don't know that much about the Genie desktop, I'm actually not going to talk too much about the main feature of the Genie desktop today, which is to actually describe and show all your measurement data that you've been collecting. And so there's actually a feature in Genie desktop where you can go and you can show graphs, TCP, IP, ICMP, CPU graphs, and you can do that simply by clicking on nodes in your topology visually, and then it will pop up graphs, and maybe at the very end here we'll show you that. But that's really sort of the key part behind the Genie desktop. The thing, though, that's been new and that we've been adding on more recently is actually the ability for you to take your experiment from creation all the way through instrumentation. And we've been focusing more on the beginning part, which was largely being done in the past by other tools, such as FLAC and the portal. So, we're getting all set here? All right, so one of the things that we've been doing is we've been working on the entry page to the Genie desktop. And the Genie desktop now, when you enter this Genie desktop and you get logged in, what you're presented with is a list of your slices now. And one of the things that you can now do beginning or right away with the Genie desktop is that you can actually go ahead and create a slice. And so the way you create a slice, there's a box on the bottom now where you can actually type in a new slice name that you would like. And you select which project you want it to be part of if you're in multiple projects. And then you simply say create slice, and it will now go off and do that for you. Now, in comparison, I'll sort of go back and forth, since some of you perhaps were a part of the earlier tutorials. If you look at the Genie Portal, they have a similar feature, so to just sort of relate that. Can we go to the portal page? Do you have one up or not? Okay. So if you go to the Genie Portal, they have options here for you to create new projects as well. And you perhaps saw this same interface here. So you can say create a slice here, and it would go off and do that. What we just did there was the exact same thing that you would have done with the Genie Portal. So there's sort of a direct mapping there. Also on the Genie Portal, you get a list of all your slices, your currently active slices, and we have the same thing here as well. Now, once you have your list here, let me first point out a couple other features we've added, and they may seem somewhat trivial, but actually several people have already found them beneficial. One is, at the top up there, there's now an FAQ/help link. And so we actually have a web page that will take you to, and it will describe several of the problems people often run into, and gives examples of here of how to fix it and the type of things that will pop up, particularly if you have different browsers and that sort of thing. In addition to that, we have a feedback link there that will actually put you in contact with us and tell us what your problem was, and we'll try to get back to you very quickly. So first of all, those are some additional features there. Then on this page, what we've actually done is we've sort of made the entire page active and clickable. So if you'll, as he mouses over these things, you'll realize that each one of these things is a box that you can click on or you can set. So we've created this new experiment called, was it GEC19X? Okay. And so one of the things that you'd like to do now is you typically want to create an RSpec and then load it and create the slivers that go along with that. You'll note right now that currently under the status it says that there are no resources present. So it was just created, but it has no resources. Now, you can go ahead and do creation of the slice one of two ways. One is you could actually say the next action here is use FLAC. That's one way of creating the slice. And that would allow you to go off and actually manually create the topology that you want. And many of you have been doing that in the past, and there was a link previously off of our page to do that. But one of the new features is that you can actually now click on the RSpec if you actually want to upload an RSpec. And so we actually allow you now to have a set of both private RSpecs that you've uploaded and you want to reuse, or public ones that other people have uploaded. So you can upload an RSpec and you can say, this is a public one, I'd like it to be available. And on this list here, we have a list information about whether it's public or private, how many nodes are currently listed in it, the name of the RSpec, and if you mouse over the name, you'll see on the right-hand side, we actually give you a description of what that RSpec is, and we also give you a graphical picture of what's going on with that RSpec. So this gives you a little bit more information than before. There's also a filter ability up there so that you can actually search through the list of RSpecs. And it will actually search the descriptions and it will search the titles to figure out which RSpec you want. So if you're looking for a particular type of RSpec, this will help you find it, which makes it a little easier than browsing them. The portal currently has almost 200 or 100 and some RSpecs, I think. So just browsing through them can be kind of difficult. All right, so what you can do is you can select one of those, and once that's selected, you'll note that it's automatically entered there. We actually take the icon, and it's to the left of it, so you mouse over that, it actually brings that up so you can see a picture of your RSpec there. And then once it's been established there, you'll note that the button changed to just simply create slivers, and it will go off at this point. And if we were to click that, it would start creating that slice for you. So at this point, it's basically done the same sort of things that you could have done in the portal, but now it's all just sort of integrated into one tool here, the Genie desktop. You'll note here that when he clicked it to create slivers, this is another feature that we just added, which was that it was very possible for you to create an RSpec that was unbound or did not match the set of AMs, the aggregate managers, where you wanted to deploy that. And so what this did when you clicked the create slivers, it came up here and said, this is an RSpec that's not bound. You need to tell us which AM to put it on. And so we just simply say OK here. And then you can come back and you can click on the AM box here. You'll note that there's no AMs associated with this. So we have to decide which InstaGenie or ExaGenie rack we want to put it on. And you can select here from the list. And then once you've selected from that list, you can pick, well, actually pick two here, just for the fun of it. This is an RSpec with is really only supposed to go on one rack. And you say set that for that. And now if you click create slivers, it should come back and actually give you a complaint saying you have two AMs and you have an RSpec that only belongs on one AM. And so it will actually tell you that and correct you in that case. So if you fix that problem now and only go back to one of the AMs, we should actually be allowed to go ahead and create this particular slice. So you can see now it's going off and creating that slice. So some people were getting into problems where they perhaps had an RSpec with predefined AMs or no bound AMs, and they didn't match with the AMs that were selected there for deployment. Another thing that we've done more recently is that we actually allow you, if you have an RSpec that's been bound to a particular aggregate manager, If you want to pick it up and run it on a different aggregate, we will convert that RSpec for you into a different RSpec for that particular AM. Okay, that's what?
That one's bound to Kentucky, and I'm going to try to put it on Stanford.
Okay, so this one was currently bound to Kentucky, and he's going to change it to Stanford. So it pops up here now and says, if this one was bound to, do you want to be bound to Stanford as opposed to Kentucky? And if you say okay, then it would go ahead and do the operation. If you had said no, then you could go back and change it if that was an error. So we're trying to cut down on some of the errors that we've seen arising when people are creating slices. All right, another feature that we've added is the ability for you to auto-renew your slice, and we've actually added on the right-hand side here is a set of the slice and sliver expiration times, which may in fact be different. So we post both of those. And we also allow you to select auto-renew. So if you click on here, and it will say it will auto-renew as long as this page is open. Okay? We don't allow you to auto-renew forever because it would just keep auto-renewing all the slices. But as long as you keep your page open, it will automatically renew for you. This is particularly useful if you have resources that go away within a few hours. So if you just continue to work on your project and it was going to go away in a couple hours, this thing will automatically renew so you can stay with it. As soon as you close your page, though, that stops. It comes up with never by default there. Okay. All right, so this is where we spent most of our time and effort. We did add one other thing. Do we have a Genie desktop that we can show there? Okay. We have changed one of our default, the logging information. The logging information here, we've updated this a little bit. There is a detail button now that you can actually click, this little blue button over here that gives you details about whatever the log information is, and that can help you debug some of your problems to see what was actually going on. We also have now added timestamps as to when those particular operations occurred, so that may also give you more information as to how fast it's progressing through the steps while creating your slice. Okay. Oh, one other thing, yes, we forgot the hide and show. Okay, so if you have a very long list of slices, many people would find that they'd have to scroll to the very bottom of their list to find their slices. We have the ability here to actually check some of the slices. You better check some of them. The ones that you're interested in, for example, and not the ones that you're not interested in, you leave unchecked. So you check a handful of them that you're interested in, and then you can simply go over here and you can say, simply show the ones that you're interested in, and it will narrow down that list. So you can see it's a much shorter list here. If you want to then, of course, see all of them again, you can uncheck them and it will restore the hidden ones there. So this, particularly if people have lots and lots of slices, this can be useful. Anything else before the Genie desktop?
The initialize and instrumentalize.
Okay, those are, they were there before though, I believe, yeah. Right? Okay. So what we're going to do is just simply take you to the Genie desktop now. There's one other new feature there that we've added in terms of demonstrating and showing graphs there. Typically in the past we had a way of demonstrating passive graphs, and that was a relatively simple interface. We have now actually enhanced that interface so that you have more control of how you display your graphs there. So all right, so you can now click on a set of nodes as you did before, and you'll note if you click on the set of operations, we have both a passive graphs and a passive graphs light. The passive graphs light is our old way of showing them. It brings up the graphs very quickly, and you can see a quick snapshot of them. You can mouse over them to see a larger view. They're kind of popping off your screen there, but this provides just a very restrictive way of seeing them. These are live graphs. They're being updated every 5 seconds. We also have the ability to do a little bit more heavyweight graph processing here, and that's with the standard passive graphs. And this brings up a window now in which you can actually change and configure the way you view your graphs, and it also gives you more detailed information about the graphs. So if you mouse over on these graphs, you actually get information about the specific data points on there. You note you can actually change the chart size or the scale of the graph there, which gives you more or less information in terms of how many points you see at any given time. You can change the offset in time that you're currently seeing. You can go back in time or forward in time with that. And you can select which graphs you want to see in this window. So it gives you a great deal more control. It's a little bit more heavyweight process, but it allows you to see exactly what you'd like to see there. So with that, I think I'm done, and take any questions, or whether wait till later, I don't know.
Indiana University, and my goal right now is to talk a little bit about an active measurement we just recently added to the GEMINI project that allows you to instrument existing applications with a wrapper library called netlogger calipers. And the idea there is, if you want to get summary statistics for an application that you're running within your experiment, it can often be difficult. You might have to recompile your application to add an instrumentation library, or you might have to think of that type of additional work well ahead of time while you're working on other things in your experiment. So this gives you sort of a simple way to take your application and collect summary statistics about common socket calls that your application might invoke, such as read, write, send, receive, so network and disk I/O type operations. And what the library does is it performs in-memory statistic summarization about all the different system events that it sees. So it basically intercepts these and creates an instrumentation layer between your application and the system. And then you can write out those summary statistics to a file and then allow the GEMINI I&M system to basically suck in that file, parse it, create different event types for all the metrics that it collects, and then have those stored inside the measurement store that runs within the slice. So, yes?
Does it store the metrics for the VMs or the host that's hosting the
Host statistics, not the VM. All right. It would be also interesting to have that capability on the physical system as well.
Yeah, because if your application is running on the VMs, then it's kind of tricky to find out what exactly is being used.
Right, that's true. Yeah. So again, this is really just sort of an initial way to get some information about what your application is doing. But again, we need to sort of go down a few. Looks like my microphone is becoming detached, but we definitely need to look at it. Ooh. Is it okay now? But yes, we definitely need to look at it from beyond just the guest OS, right? Look at different layers. So what I have here is a slice that I've already instrumentized, and I'll just take you through the process of how I would log into the node and use the wrapper library to gather these summary statistics. So here I've already used that filter feature, which I just learned about on the desktop, which is very handy because my slice list was getting out of control. So I will click on the Genie desktop, and hopefully this will work. All right, there we go. So within here, you can see that my slice topology is very simple. It's just two nodes that I'm going to run this test on. I'm going to click on the launcher icon, and I'm going to go to global node and I'm going to open up the Periscope config interface, psconfig. And this loads the web graphical user interface that allows us to configure active measurements that our measurement collector blip runs on the individual node. So I'll go to schedule blip test, and I will take a look at what's currently configured. So now I will get a node list. And you can see that I currently have, on the node VM, I have 2 probes currently configured that blip is running. And one of them is a netlogger probe that's collecting information about an Iperf process. So it's very straightforward. I have an existing Iperf network benchmark, and I want to get some summary statistics about what it's doing in the network. And you can see that what it's collecting now are information about write events that the application is generating, and then a bunch of summary statistics, which I won't go into detail here. There are in the tutorial page, but it basically collects the value that each of these calls has produced, and then over a given interval, it will compute the sum of the min, max, standard deviation, and for both the rate, the actual value, and the gap value, which is the duration over time. Sorry, the duration over the value. So how I would actually configure this is to configure the node to actually collect this data is log onto the node. Let's make this a little bigger. And you can see I have Iperf on this node, and I have the wrapper library, which is present when the slice is instrumented. So if you go into, sorry, wireless is very slow. So there's this shared object called NL wrapper, and we use the Linux preload mechanism to invoke the wrapper for a given shell. So I will do export ld preload equals user local lib NL wrapper. So now any application that's invoked from this terminal is going to basically use this wrapper library, and the wrapper library will write summary statistics to the file that's specified by this environment variable. So in this case, I'm just going to write it to iperf.nllog. And you can also specify the summary statistic interval. So you can specify NL interval, and you can do summary statistics over 1 second, which is the default, up to whatever you prefer. So let's do an Iperf test to the other node in this slice, which is VM0. It's at 10.10.1.2. And I will start running it. And then I will also tail the log file that I asked for. In this case, you can see that it's writing a bunch of summary statistics here. And you can parse this file manually. You can do whatever you want with it. The trick here is that we have the wrapper library, and we also have an agent running on the node that can parse that output and actually send it to our measurement collector or measurement store, and you can archive it, you can analyze it, you can look at graphs. So let's let this run for a while, 2 minutes, and we'll go back to the probe, and you can see that the way I configured it when I added this probe was to give it a description, and then you can actually configure the blip agent that's looking at this file to look at it every 5 seconds or some other interval. So this basically tells the agent, look for updates every 5 seconds. Where is the file? And I can report statistics to the measurement store every certain number of collections. So every number of times the agent aggregates the statistics in memory, it can then push them to the measurement store. So you have control over those options. And then for each of these, you can then bring up a graph that shows what is currently collected. Let's see if data has shown up.
So is the data stored available through the Persona measurement archive API?
This is a measurement store that have been developed for Gemini, but is also a standalone component, and the schema is based on the existing Perf Sonar and MWG schemas. So there's a direct relationship between them, and we have a RESTful API for accessing the data in the measurement store, as well as all the metadata in Unis. And there is documentation on how that is actually accessible and what format to use. And for some reason, I don't know if it's the network or something else, but it doesn't even seem to be looking for. So it's possible that my network just died. Oh, there's something. This has been on and off all day, unfortunately. I'm sorry? Oh. We're really into unknown territory. Set up MS Chap settings. I might not have the root CAs, but it looks like things are actually coming up. So, but thanks for the effort. It just took a while. All right, but now my Wi-Fi adapter is reassociating. But you can see that data is there and it's showing up, and you can view it using this graphing tool. But you can also, like many people are interested in actually getting to the raw data, and we should update all of the pointers to how to do that, and that's something we'll do in the near future. I guess the other thing, I don't know if I have access yet, but you can also look at the logging of the measurement collection agent. So if something goes wrong, or if you want to look at the format that is actually being sent to the agents that's doing the actual collection, you have a way to look at it now through the web GUI. And we're still working on filtering this a bit to make it much easier for users to parse and see if there are errors and make sure that it's actually successfully collecting what you asked it to collect. So I think that pretty much sums up what I wanted to go over. And I will also mention that we'll be doing this in detail tomorrow during the tutorial. Here's the tutorial page. All of the features I just talked about are under this last link, Advanced Monitoring. And I'll just show you the page. But yeah, everything is here accessing the web GUI. So you can try this out on your own time, and you can join us tomorrow to go over it in detail. Thank you.
I want to apologize up front a little bit. This is my third presentation today, and we have a demo session tomorrow, so if things are a little bit chaotic, please be with me. Thanks for joining for me. I'm paying you. So bear with us, but hopefully we can show you some interesting stuff, and I'd be happy to get some questions. So if you run into anything, ask at any time. What I want to do just a little bit different is before I go into actually demonstrating what we go, some of my students have to be out here. We go into demonstrating GEMINI. 1, 2, 3, check. Oh, much better now. Huh. I want to show you a little bit the inner working so you understand what are the moving parts, where's information flowing back and forth, and what's going on here. so you get a little bit of an idea. You know, again, building tools to allow your measurements on Genie testbeds. You know, Kong Wang and Divyashi Bhatt have done a lot of work, and I also have Peter Blum and Ishwar Kishore with me who are working on some of this stuff here. So for some of you who are new, you know, there's this experimenter cycle we have in Genie. Maybe you heard about this morning already. If you have gone to one of the tutorials, you know, we're thinking about designing and setting up an experiment. We execute an experiment, collect the data, and then hopefully have some wonderful results to present. Actually, I just realized I should update this slide because it doesn't matter which test bed you're doing this with. This is a little bit an older slide, unfortunately. So, you know, sometimes you want to use that, and that's what we're going to show tomorrow in the tutorial by using a simple topology, but you're not limited to that, right? You can do very complex topologies. People who have been at the GEC19, you know, Thierry showed a very nice tutorial with, you know, many, many nodes for how you can actually do this to run a BitTorrent experiment, right? So, but we want to make experiments repeatable, right? This is one of the things that are really important. We want to be able to run experiments over and over again because we want to get statistically meaningful data from our experiments. Right? So a runoff experiment is not a good idea. So how can we make this easier for the experimenter, and then, you know, allow ability and documentation for the experiment. And so one of the things we think is this experimenter cycle, and I have my, you know, my old joke here by now is the successful experimenter cycle that you go so often through it that, you know, most of us can have a publication out of this. This is usually the goal we're working for as researchers, right? So how do we do this? And so you know, Maxart from NICTA has come up with a tool we're using here in GIMI, and that's called LabWiki. That allows you to kind of streamline this a little bit. So when you look at LabWiki, what you see here is on the left-hand side, you see a real wiki, which is, you know, kind of the electronic version of your good old lab book, where you can take notes about your experiment. You can actually store results. You can, you know, have some graphs on it and all this stuff. I'll show you a few things in a moment. And then what you have in the middle is actually a pane where you can prepare, where you can actually either edit your lab wiki or your experiment script, which describes how you execute a specific experiment on a slice you have reserved. And I'll get to that in a little bit more detail in a moment. And then on the other side, you can just you know, execute your experiment and observe your experiment, and I'll show you that live when it's running. So you have kind of three different ways. You have the wiki, you have the edit, and you have the run. And the cool stuff is also, if you're someone like me who cannot remember things for a long time, there's actually searches on top. You can, like, you know, oh, I had this wiki that was called IPv4 ping or something like this. So you start searching, and it completes you and shows you what you have in your Git or in your iRots repository here to help you remember a little bit. The nice thing about LabWiki is that it's actually kind of a modularized a tool, I should say, that allows you to, you know, if you're really interested, bring in your own plugins. We just talked about this a little bit, in the earlier session. What we are using are, you know, we have a plugin that communicates with the portal. I'll show you that in a moment. With the with the Orbit measurement framework, which is what helps you coordinate your experiment, writing a script that then gets executed at the remote nodes in your slice. Some services, and then an interface to iRots, which allows you, iRots is a storage system which allows you to long-term store your experiments. And then, you know, potentially there could be your service in there for some of that stuff. So don't be scared by that next slide I'm going to show you, but these are kind of all the moving parts you have when you run an experiment on Genie, right? So you start with step 0. As a good computer scientist, you start with step 0 by reserving a slice here, right? We're just taking here what's just an example topology from a Genie testbed, and then you instrument that slice to be able to perform certain measurements, to perform the data, to obtain the data you want to measure. And you collect that information, right? It doesn't just, you know, you have to put that information somewhere so you can use it later on for analysis. Collecting that data while you're running your experiment. And then, one thing we're doing is you can live plot it, and the other thing is you can save it to obtain it later on for, analysis and going through all these parts. Now, what we're trying to do in our project is actually kind of, automate most of the steps here to make it easier for an experimenter to run experiments, right? So that's kind of, the goal. But to do this automation, it requires a few things. And so what I just want to say is, like in earlier tutorials and throughout the tutorials in these 3 days, you should have learned about Genie accounts and credentials, how to create an iRods account, know what resources are actually available in the different Genie test beds, how to create a slice, how to create a slice request, how to reserve a slice, and how to log in VMs of your slice, right? That's kind of, things I kind of assume you kind of have seen that in the tutorials today, or will see that in the tutorials that are happening in the next 2 days. Now, should have been covered in the tutorials today, if I remember the agenda correctly. And kind of that has made you familiar with the Genie Portal. Can I, just by sign of hands, say if anyone was in a tutorial today where they learned about the Genie Portal? Cool. At least one. Excellent. So I can go over this quickly for a moment. I think we have a little bit of time here. So just tell you a little bit about the inner workings. So we have been in the Genie Portal, and we have been able to get a slice like this. This could be any slice. I'm just taking this for an example here, right? This is a slice here, consists of a bunch of nodes. And so this is your slice, your experiment topology you're using to perform your experiment. And that's just nothing to do with GIMI yet so far, right? This is just something you brought up. And now how does GIMI come into play? So we're taking our slice, and then we're running a persistent service here that has different services run on it. So one of them is the OML server, that's the orbit measurement library that collects the data. We have an aggregate manager and an experiment controller. Then an AMQP server that helps with communication, an interface to iRods to store the data permanently, and then LabWiki. So these are all the services we're providing for you. Right? They're running there, and everyone in the Genie community can use them to use experiments. This one is running in the slice, right? So just keep in mind, this one is, we don't have any serious issues, should be up and running all the time. This one comes and goes depending on how you create your slice or release your slice. Right? And so what's important is, first of all, how do the nodes and the controller talk to each other, right? Now, this is 5 nodes. Think you want to do a 100-node experiment, right? With 100 nodes, you cannot just manually enter that in each node. You cannot SSH into this and all this. So what we do is actually that we use a messaging service based on the AMQP, where the nodes register with the AMQP server and the experiment controller register with the AMQP server. And since they have a unique identifier, they can find each other, so to speak, and then you have the communication channel open to run your experiment. So from the experiment controller, send control information to the nodes to execute whatever you want. And I can actually show you, or will show you later, that you can even run a shell command if you want to do that on a node, right? That's one of the things that are possible. And for sure, measurements, right? So what we have on the nodes are actually, oh shoot, this is not turning out well, right? So it says, in these very bright boxes, it says RC for resource controller and ML for measurement library. So we have a resource controller that, you obtain certain control over the resources and can execute certain things, and the measurement library is how you collect data and send that back to the online server for collection, right? I'm sorry that the color scheme I picked is obviously not a good one. I want to add in addition that when you run experiments and want to use GIMI tools, that we provide images with the tools for InstaGenie and ExoGenie. So we will provide these images that are available. So when you bring up a slice and choose one of our images we provide already, it comes with an RC and an ML already installed, pre-configured, and so you can use that for your experiments. Go ahead.
Did you change the MQP server to AMQP server?
Yeah.
So why?
So I just, Max, they made this change in OMF6. and he said there was some performance with the XMPP server. He says AMQP is much better performing in this case. So, you know, it doesn't matter actually for an experimenter. It looks exactly the same, right? You don't feel that. Right? It's just a different technology, different implementation. But I want to come back to the slices. You can also use these slices then as a basis for your experiment, and you know, expand them or extend them with pieces on there you want to have on there, like you guys doing, for example, Hadoop, right? So you can actually use a GIMI slice and then install the Hadoop tools on there to do a Hadoop experiment and measure certain characteristics, some bandwidth, CPU load, memory usage, and other stuff, and then on our end, and get this information. Okay, so this is how the nodes talk to each other, how you kind of orchestrate your experiment, and so through the AMQP, then the EC can directly talk to the resource controllers, and you can run, you know, experiments. I'll go into an example pretty soon. And then when the experiment has started and is running, the measurement libraries will send back information about your experiment to the OML server, and then you can, if you want, if you see some data you think, ooh, this is cool data, I want to save this. So when I sit at home tonight and can think a little bit more, I can go and pull that data out again and, you know, have some good thoughts about it, analyze this data and so on. And then LabWiki comes into play by actually talking to the experiment controller and the OML server, because we need that for from on one side to, you know, instantiate and run an experiment, and on the other hand, LabWiki talks to the OML server to get data and to display it for live observation. So the steps you do to run an experiment is, you know, you serve your slice with VMs that boot GIMI images. You verify that your slice is up. You define experiments to be executed in LabWiki. Run and observe the experiment. Archive results. You can document the results. You know, this is always, again, if I take me, it's good to like have some notes with it so I know next week what I've done there. And then when you're done, delete the slice, right? We're actually coming to the point where, thankfully, more and more people are using Genie testbeds. We're really happy about this. I think that makes us all very happy. But it's also that there's a little bit of contention, right? So especially before GECs and so on. So if you're really done with your experiment, delete your slice, because now you're making the resources available to one of your colleagues, right? So being a good citizen, I think, is what I think. So before we go into more the demo part, if you want to know more about this, there's actually sample assignments online you can use, right? So if you want to go through some of the stuff when you're not at a GEC, that's possible. There's actually demo night coming pretty soon. You know, Kong and Ishwar and Peter are going to be then showing some of their stuff, and they're going to have good food and some drinks, so it's definitely a reason to go there. There's our tutorial tomorrow at 1:30, where we show you how to actually instrument a node, how you write your own application. And then there's the OpenFlow tutorial with LabWiki on Wednesday morning at 9. So you've got to be a little bit of an early bird. So, but there's more options if you want to go deeper into all of this. Let me just switch over here and see if I can pull this to the side here. So if you look at the Genie Portal, some of you have seen that already. Oopsie, I should use this guy over here. It's actually not me. It's like this projector's a little bit funky with the colors. The map's not so important right now, but when you're logged into the portal, you see actually the projects you're a member of. If you want to be a member, you can request membership. I'm actually using my student's account at the moment just for demonstration reasons. But as you can see, he's member of 2 projects. We just take this for a second. You can create a slice. You can give it a name. You've seen that before. But then, you know, when you want to add resources to it, and I don't know, this is something we should, you know, think about in the future, if we can actually, how we do this with slice names and the aspects, because now we have already specific aspects. So see, you know, there's Gemini aspects, and you guys please chime in the aspects you can use for some of your experiments or certain experiments, I assume. And then there's also GIMI aspects, and that bring up already certain topologies with with our images installed. So if you want to get, learn a little bit about it, it's probably a good thing to use one of these aspects to have these resources. And actually, I wanted to mention something that's already there. They are pretty clearly marked. So if you, for example, go back to the GEC19 tutorial, this is an aspect that we used in this case, right? We have some load balancing and some, sometimes we do tests, obviously, for demos and so on. So this is how you can pull that up. And then, if you pull an aspect up and you reserve your slice, you can go over to flag. Everyone knows what flag is, I assume, and see the slice there, right? And so the good thing is actually that we go here, we go back to the projects. We have connected the clearinghouse portal with the with LabWiki, and so just bear with me 1 second. Here's a couple slices. There's actually two sample tents actually in 2 different projects. Very cool. So here you see 2 different slices, right? And so let me now switch over. Where's my tab? Where did this go? Oh, sorry, I have this on a different browser. Too much stuff open today. That's why I asked to bear with me a little bit already earlier. If you open the LabWiki here, and if you run an experiment, so let me go through this a little bit more carefully here. If you want to run an experiment, I will show you that, when you, this guy is like me, needs a memory refresh. And now I'm running in the same problem. Ezra was running in. No, actually it's not that slow. But you can see that, here's the linking I want to talk about. Here you see, in the portal there was membership for 2 projects shown, right? So that information is automatically transferred between the portal and LabWiki. And then you actually see all the slices that are available. You saw, I just made the joke about sample 10, so that's here. So you have that. And then if I get this fit somehow in this frame here. Oh, I don't know. You can see that. So something is. Still loading. All right. Okay. It's the network a little bit, I guess. So if you see that here, we can then, I apologize, this was just a little bit slow. I don't know why this is not. Okay, now it's over here. Again, we can now choose the right slice, the right, and we can actually start the experiment. Before we get there, I just want to show you that, here's actually where you define your experiment, right? And we'll talk about this a little bit more with a little bit more time during the tutorial tomorrow. That gives you some information, but we just, I mentioned running just, oh no, I'm the wrong one. Here, if you go into step 2, you can see here that, you can actually execute shell commands, right? Here we're just setting simple routes. This is actually one example I took from a class assignment we're doing with students, where we have them use LabWiki, where they just learn a little bit about routing. And you can see actually that you now have groups, right? You can define your groups. Here, this is only simple. This is 2 nodes we're defining as a group, right? But you can actually define a lot more nodes into a group. And then you can if you do an execution, if you say, group node 1 or whatever, execute, then it gets executed at all the nodes automatically, right? So you don't have to do this step by step by step by step. And so this is how, you have a little bit of definition. On event all up tells you all the nodes reply back to the experiment controller and say, hey, we're up and running. We can start the experiment now. And when this is all up, we can actually, the experiment is executed as defined here. And again, we'll go through this in a little bit more detail tomorrow about what's happening in an experiment. And then in the end, not for that one, so sorry for hopping back and forth. But if we go back to the step 1 experiment, in the end you can actually define a graph that shows you, allows you to live observe your experiment. And so, well, since this is going to take a short moment, excuse me, I'm just going to start it right now. This will start now the experiment. You see this is in a pending state. It's going to take a little bit to run. And on the other side, we actually have a description of this experiment, right? So this is something we have prepared, but you could do this yourselves by showing certain, or by just taking several notes. So when you pull this back in the prepare pane, then you actually can go in here and edit it, save it, and then you have the updates here on the other side. The pending should be running pretty soon. And so, it allows you, for example, to give references. We have, for this case, since this is a classroom experiment, we have created several videos that tell the students, give the students some extra information, how to set up slices and so on. We have some things about the topology and so on. This guy says it's running here. So the experiment is now running. And it might be, oh, this was actually really quick. So here you see actually the graph plotting at the moment. This is just something we do for the students when they bring up a slice. We have them run a ping so to make sure that the connectivities between all the nodes are up, so they get a little bit of an idea about how we do topologies, what's going on, and we just report that ping back live. So one of the features you can have here is actually that when you're done with, when this experiment is done, you can actually go back and say, well, this is something I want to keep in my notes. This was kind of something interesting I saw. And then you can actually save it here in the lab wiki. And then you can go over and run your next experiment, maybe save it, throw it away if you didn't like it, and then go on. This is still running. But that's kind of the basic concept. Let me pause here for a second and see if you have any questions. Okay, great. And so this is, there's lots of different ways of experiments you can run with it. The flexibility here is that, this is using something, this is using an application that already comes with OML. It's called the ping wrapper, right? It's a little wrapper application that's written around the ping that takes the ping information and sends it back to the OML server. But you can, OML libraries are publicly available, so everyone can write their own application for whatever they want in their experiments. Divya is going to show tomorrow how you can do this for a layer 2 ping. So you can write a wrapper around a layer 2 ping, and so you instrumentize your own application. Yeah, go ahead, Ezra. All the raw data, the measurement data goes first of all into the OML database, and then when the experiment is over, whoops, I should get a button. Maybe I'm not seeing that. When the experiment is over, here, this one, right? You can actually dump it to IROTS then. It goes into, IROTS is the database, and then there's an interface. There's an interface name. I always forgot the interface for the what's the web? iDrop, right? There's a web interface that allows you to browse in there, to get in there and then get this information. Okay? Come on, you want to show the 2-node thing? Okay, yeah, so, excuse me? Yeah, I'm logged in as Ishwar right now, so yeah, I don't know if you want to, yeah, come on, if that works. So, short switch here. Kong is going to come up, and we want to show you another simple thing because this is one of the things we got in recently is actually that, I told you about images we can run now. We have images for both test beds for InstaGenie and ExoGenie. And it's just going to show you a simple experiment where we have a VM running on InstaGenie. There's stitching going on between InstaGenie and ExoGenie, and we have a VM running on ExoGenie, and just show you how that goes, or that you can run an experiment on top of that. Yeah, I think you that's tricky, I know. So my mistake. Here you go. So, and just show you, and so this opens actually a complete new door, right? If you really want to run a large-scale experiment, and you can stitch two test beds together, then all of a sudden you can use all the InstaGenie nodes on one end and all the ExaGenie nodes on the other end, and run like, I don't know, what's the count right now? Victor, what's the count on VMs on the ExaGenie side? Minimum 500, even more, right? Yeah. So 500 and greater on the InstaGenie side is probably even a higher number. So you could like run a 1,000 node experiment if you really talk about scalability in Genie. So can you go back to the portal and show your slice and fleck pretty quick, if you don't mind? Yeah, no, don't log in again. Go away all the way. Or does it remember you? Good. Let's launch Fleck. Just launch Fleck. So you reserve that with Omni, right? So stitching is still especially inter testbed stitching is still a very, it's a little bit of work in progress, I would say. It's working, but it needs to be solidified a little bit more. So you really can't use Fleck to do the reservation. You can use Omni, which is another tool to make slice reservations, resource reservations. And but if everything goes fine with the Genie AM API, you should actually be able to see that in Fleck here. So just give it a second. It's going to come up in a moment. But why don't you run the experiment on LabWiki? Sorry, I'm driving him crazy by changing my mind, but I'm sorry. And then we can actually show the topology in a moment. So this is again simply just a simple ping here in this case, but here's your slice just to show that we run this between two experiments. You're using 4609? Okay. So that's gonna again take a moment. We have a job scheduler behind that, so it takes a moment until that's submitted and starts running. Just go over to Fleck for a moment and check what's going on there. Should be up there. Yeah, so you can actually, I had a link open, before you had to, LabWiki and the experiment controller were very closely tied together. We're kind of linked together in a hard way. So if you LabWiki, if you took that down, your experiment would go away. Now they are detached. You start your experiment, and it goes into the job scheduler, and it runs on. Here you see actually, whoops, wrong way. Go forward. Excellent. And just hit the reload button. Now this is detached, so that's why, LabWiki sends that experiment script over to the job scheduler, and then the job scheduler has to be up and running, obviously, all the time. But LabWiki doesn't have to, and your experiment will run to the end. Here, all the jobs Kong has run already today successfully, so it's been busy. So you see the graphs working. So this is not necessarily super exciting. The really exciting part is that we're using two different VMs on two different Genie test beds, and we've been working on that quite a bit to get this going. So that's pretty cool. Can you go back to Fleck for a second? Yes, we're using a stitcher. No, so actually it seems that that's not displaying. So you got to trust us in this case. I'm sorry. With the resource. Sure, you want to see the aspect? Be happy to do that. I think this is basically what we wanted to show you today. Again, stop by at Demo Night and all the other events I mentioned on my last slide if you're interested. But before we stop, I'd be happy to answer any further questions. Okay? Thank you. Thanks.
And close the tab, as long as you don't log out here. If you log out here, and LabWiki will automatically kill your job because it needs to keep the resources like shared by everybody. So if we go ahead and close this button, and we can do something else. Maybe you go to flag or play something else. And then after a while, when you come back here and you go back to the same page. Okay.
Not further down.
Last one.
Yep.
Okay, here. And you search for your experiment. And you can continue seeing your figure here, and it will still be the live graph, I think. It will continue until the experiment finishes.
In 70,000 seconds. So that's what I just explained a little bit earlier. That you can start your experiment, you can go to bed, and in the morning you can fire it up again. Just look at whatever you have running on your graph, what you're showing, and come back and see wow, it died for whatever reason, or it's still running, and you can go on with other things. Cool. Thank you, Con. Screen for LabWiki, so to speak, which is very important. It's kind of a minor detail which helps a lot. You want that? Oh. Sure.
Yeah, that's something that actually has been asked for a little while now, to have the long-running experiments. Because our experiments are getting complicated and run for a long time. So yeah, I just wanted to finish up. If anybody's planning to do the Gemini tutorial tomorrow, it helps with the resource assignment if we can set up slices ahead of time. So if you want to let us know if you are planning to do it, are signed up for it, and we can give you some information, a rack and an RSpec, to set up your slice ahead of time, and that'll make things go a little faster. So just flag Hussam or myself, and we'll get you set up. Any last questions? Those that are running experiments right now are interested in instrumenting them? Okay. All right, well, thanks for your time today and taking a look at these, and please check out the tutorials going forward, or feel free to send questions to the Genie users list, and we'll help you out. Thanks.